In this video, we're going to walk through setting up the automatic parts loader on this VF2YT. Just like on our lathe APL, the Mill APL interface offers step-by-step guidance through the entire setup process. So even a novice machinist or operator should be able to get set up and have the APL loading their parts right away. We think you'll find the setup process becomes familiar quickly once you've had a chance to use it. On this unit here, we have this template for locating 60 pieces of 3-inch square stock. In order to locate your particular workpiece shape correctly, you'll need to fabricate your own template to fit your part's geometry. You'll find table size and pin location dimensions in the user's manual. And we'll talk a little more about some ways to create templates at the end of the video. There's lots of useful information about APL part size and weight capacities, and template dimensions on the machine layout drawing found on the APL main page at haascnc.com. Let's set up our part. We're using these 3x3 aluminum blocks, and there are a couple things we need to take care of before we start the APL setup and the control. I've already positioned the fingers on gripper number 1 so they open slightly wider than my workpiece, and they're evenly spaced on the center of the clamp body. The material we're using is, of course, raw stock. Next, I position the fingers on gripper number 2 to hold the finished part in the same way. A decision will need to be made regarding the best location or feature to hold the part from when removing it from the vise after machining. I've chosen to grip these machined walls here. The part cutting program should be ready and in the controls memory in order to get started. Don't forget to put an M299 at the end of the program instead of an M30. This will activate the APL when in APL mode. The soft jaws for the job should be installed on the vise and machined as necessary. And the vise grip pressure should of course be adjusted, as well as the vise air blast lines. When setting up the APL, there are 4 important reference positions that we need to teach the APL. Number 1 is the raw stock initial pickup location from the APL table. Number 2 is the vise load location with gripper number 1. Number 3 is the vise pickup location with gripper number 2. And number 4 is the table drop-off location of the machined part. There are plenty of additional values to input during setup, but these are the 4 main tasks we'll accomplish. And luckily, the Haas control and APL interface will display images, text, and animations to make it clear what information the control needs along the way. So let's get started. First, let's press the current commands key. Highlight the Devices tab and navigate to the Automatic Part Loader tab. There are 4 tabs under the main APL tab: Template, Load Part, Unload Part, and Run Job. The entire setup process consists of filling in all the required information on each of these tabs. We recommend going through them in order from left to right. Once you are familiar with each of these, you can navigate and fill in the information in any order you want, as the outcome will be the same. The Template tab defines the table grid pattern and the part information. So let's start defining things. Arrow down to the first line labeled Part Type. And now let's pause to look at this line here between the image and the data entry fields. This line gives you instructions for entering values in the data field you have selected. I'll leave Part Type set to 0 since I'm using slug type material. If I was using a longer piece of bar stock, then I'd enter 1 for bar type material. Next, we'll define the number of rows on the grid pattern or template. The rows count from front to back as shown on screen. Our template has 6 rows. Then we'll set the number of columns in the grid. The columns are counted from left to right, and we have 10 of them. Next, I'll enter the center-to-center distance between each row, and then each column. In our case, this distance is 113 millimeters in each case. Okay, so we're done entering the table grid pattern and part information. Now let's move to the Load Part tab. Here's where we'll define how we load our part. As you move from line to line, you'll notice that the animations here change to show you what actions to perform as you set each value. These animations loop, so if you miss part of it, just keep watching until you see it all the way through. First, we have gripper number 1 clamp type. The included grippers allow either OD or ID part gripping. I'll enter 0 to OD grip my part. The next line is the gripper number 1 clamp delay. This is the amount of time the grippers will wait after clamping the part before a linear move is initiated or after it's completed. This helps ensure that the part is held properly before moving away from the table. We recommend leaving this at the 2-second default value. Now it's time to start manually jogging the APL. The APL comes with a remote jog handle, which we'll use to get up close while we're setting pickup points and clearances for loading and unloading. We're using our touchscreen jog handle here, and you'll find that it makes some of the tasks, like selecting axes and jogging the APL, easier than before. The decals here show us which axis is which. Just like on the lathe APL, AV controls table motion, AU controls the side-to-side position along the bridge, and AW controls the up and down movement of the ram. I choose the active axis by touching the select arrows here on the left or by just touching the axis readout itself. And when it's time to grip the part, I actuate the grippers by touching the corresponding number 1 or number 2 cells here on screen. All of these controls will quickly become second nature, just like moving the machine axes on your mill. If you don't see the AU, AV, and AW axes all on the RJH screen at the same time, then go to the position screen, press Alt and check the XY, AU, AV, and AW boxes. Uncheck any other axis so that only XY, AU, AV, and AW will display on the RJH. Okay, time to move the arm into position. First off, if the arm isn't close to home position, you can quickly move it by pressing Insert on the control or Move on the RJH. This commands the APL to move automatically to the above table position. This can save manual jogging time and gets the grippers close to the initial pickup location. Just make sure that the AW axis is high enough not to hit anything. Next, we'll press the handle jog key to allow the remote jog handle to jog the axes. Then press current commands again to return to the APL screen. Okay, let's pick up the first slug in position number 1. This is always the furthest lower left corner. I will move the 3 axes using the RJH until I have the jaws centered over the part. And in this case, I will grip about halfway down on the part. This is where you'll need to decide how much of the slug you'll leave hanging out for the vice jaws to grip. My vice jaws are about 150 thou deep, and I'm gripping halfway down on this 0.75 thick block. So that should leave plenty of room to grip it. Even though the light curtain here is active right now, when I'm in jog mode, I can interrupt the beam to get a good look at my alignment. So move wherever works best to get a good look at each side of the block. Once I have the gripper positioned where I want it, I'll close the gripper by pressing the number 1 button on the RJH. Once the part is gripped, you can fine-tune the position in the AU and AV directions. When you are happy with the position, press the record button on the remote jog handle or F2 on the control. Now let's arrow down to the ready location line. With the part still held by gripper number 1, you can jog away from the table vertically using the AW axis. Remember that you rotate the jog wheel clockwise to raise the ram upwards. Once you're a few inches above the table, you can press Move on the RJH or Insert on the control. This will initiate an automatic move to the ready position. The ready position locates the arm close to the machine in preparation for the doors opening. Make sure there is clearance side to side and top to bottom on the enclosure, and also clearance for the door handle to open. I'm happy with the clearance I have here, so I press record. Once the ready position is set, with the arm positioned with a little clearance outside the doors, we'll move on to setting the load position for the APL arm relative to the mill table. But first, we need to open the doors so the arm can get through. Press the auto door activate button on the side of the pendant. In a second here, we'll be jogging the arm with AU and AW and the table along the x-axis until the workpiece is where we want it relative to the vice jaws. When we're happy with the workpiece location, we record the position of the table on the internal axis location for load line here. Then we record the arm position on the vice location for load line here. And it doesn't matter which one you set first. Now usually you'll be loading the vice with y-axis all the way forward at a machine position of y0. So really you'll only be concerned with alignment of the x-axis. One other thing, if you want a particular tool loaded in the spindle before the part is loaded, change to that tool now. All right, let's get our workpiece lined up. Generally speaking, you want your x-axis position to place the stationary vice jaw within 20 thou of the workpiece. And you want to bring the AW axis down until the workpiece lightly contacts the bottom of the jaws. You'll note that we've added a light chamfer to the base of the jaws here to ensure the jaws don't catch on the workpiece edge as the jaws close. Okay, I've jogged around until I'm happy with my workpiece position. Now I'll press F4 to automatically actuate the vice. We're using a pre-production version of the Haas e-vice here, but functionality will be similar whether you're using a pneumatic or electric vice. So my workpiece is clamped, and I'm happy with the axis positions, so I'll record these on both lines here. Now I can unclamp the grippers, and we'll set the final line here called alignment. This just sets the vertical height before the arm exits the enclosure. In this case, I'll move upward about half the way between the vice and the top of AW travel and press record. Now we'll jog the arm back until it's over the table and we can close the door and machine our part. Here, our part program is already made and the program is active, so we'll proceed with machining the part. But we don't have APL mode activated right now, so the APL won't try to load or unload our part, which is good since we haven't finished programming the unload steps yet. So let's start our part. All right, our part is machined and we are ready to retrieve it and return it to the table. I'll open the doors, blow everything off, and we can finish this APL setup. Now, let's arrow over to the Unload Part tab and start answering the questions. On the first line, I enter 0 again for OD gripping, since we'll still grab it from the outer edges. And I'll leave gripper clamp delay at 2 seconds like before. Now let's move to internal axes location for unload. We'll jog with AU back inside the machine until gripper number 2 is located above the part. Now, just like when we were loading the part, we'll use AW, AU, and the x-axis to set our alignment to pick up the finished part. In this case, our x-axis position is very close to the first one we set, since it's a square shape and we're still gripping on the outside. Our AU position is, of course, the one that changes a lot here, because we are now coming in farther to use gripper number 2. Here, of course, I'll set my AW position so I'm high enough to engage the machine walls of the part. Then I press number 2 on the RJH to grip the part, and I'll record the positions of the axes on both the internal axes location and vice pickup location lines. Moving to the alignment line, we'll press F4 to unclamp the vice, and then we can move the arm upward with AW and set our vertical exit position, pressing record again. Like before, we'll jog the arm to outside the enclosure and close the doors. Now let's set our table drop-off location. We can push move to get the arm back home quickly. We'll jog AU, AV, and AW to line up the part, now held in gripper number 2, just above its empty space on the template. The drop-off pocket is the same one where you picked up the part earlier. We recommend dropping the part off at about 50 thou or 1 to 2 millimeters above the table. We've reached our drop-off location, so we'll set this position by pressing record on the RJH or F2 on the control. With that set, I'll unclamp the part by pressing number 2. Now move AW upwards to mid-level. The last line on this tab is air dwell time. This is the duration of the air blast for cleaning the vice jaws, and we recommend leaving this set to 2 seconds unless, of course, you find you need more cleaning. Now let's move to the final tab we'll complete before running our job. The first 2 lines will provide information after the APL is running. The first line tells you what part is currently being loaded or is already in the machine. The second line tells you what part is in queue ready to be processed after the current part. The third line tells you how many parts are completed and on the table. There is a visual aid shown on the right side of the screen, and it is defined by the template description we did on the template page. The current part is shown in yellow, and the completed parts are shown in green. Moving on, the fourth line provides a part count limit. Here you can input the total quantity of parts you want to run. You can input a value that is less than the amount of parts on the table. The APL will stop processing parts once this amount is reached. You can also choose a value that exceeds the number of parts that fit on the table. The APL will stop for a table reload once all the parts in the table are processed, but it will keep counting parts until the total amount is reached, even if it takes multiple table loads. For example, the table grid you are using might only hold 20 parts total. But if you enter 60 pieces on the total parts line, that means the APL will process and keep counting 3 table loads until it stops and completes the job. The next line is a rapid speed override. This rapid override applies only to APL motion. It is designed as a precaution to use when preparing a setup or for loading and unloading heavier parts. We recommend doing the first couple of parts anywhere from 5% to 25% to be sure all is set correctly. Next is slow rapid distance. Basically, this slows down arm motion before reaching the table or vise for part pickup and drop-off. We recommend 1 inch or 25 millimeters as a good starting value. The next line is the speed that it will slow down to. This speed really is application dependent. If you want the grippers to approach the table or chuck with caution, we recommend a value between 25 and 50%. The final line is a display that cannot be modified. This displays the current status of the APL and describes each step as it is being performed. Now that we have our APL job set up, let's look at how APL programs are saved in memory, loaded from memory, and how to start a new job. We'll also explain what APL mode is and how it works in conjunction with the part program. We will start with the buttons at the bottom of the screen in order from left to right. The Insert button is used to turn APL mode on or off. When APL mode is on, it activates all APL motion as programmed. Switching to APL mode also serves as a quick way to save the current APL program being worked on. When an APL program is not saved, the program name on top of the screen is displayed in red text. When the program has been saved, it is displayed on top of the screen in black text. The naming of programs is limited to the display space, and it is not case sensitive. The F2 New Job key is used to clear all of the information from the APL tabs to start over. Be cautious when using this button, since it will erase all of the values you currently have entered unless you've already saved them by pushing F3. In other words, you'll usually want to press F3 first to save your existing program and then press F2 to create a new one. The F3 key is used to save the APL program that is currently being created. Press the F3 key and this will bring up a directory. Use the cursor up or down arrow keys to navigate to the user data folder. Arrow left to enter the folder, highlight the My APL folder, and arrow to the left to open it. When you see the Save File window, enter the name of your file on the input line and press Enter to select this name and save it. If you don't enter a program name, the control will default to the name apljob.xml. Anytime you want to save a modified program or newly created program, you must enter the program name. The names must match or it will be saved as a different program. We recommend saving the APL program with a name similar to the part program name, so you'll know what part the APL program should be loading and unloading. You can also save pictures of the grippers and jaws for future use, and even use M130 in your part program to easily view these pictures. Finally, the F4 key is used to load an existing APL program from the My APL directory. Press the F4 key and navigate to the My APL folder. Highlight the program you want to load and press Enter. This will load the 4 APL setup tabs with the appropriate information. Also, for the APL to run in a loop until all parts are done, the part program must have an M299 at the end instead of an M30. If APL mode is turned off, the control reads the M299 the same as an M30. There are more details about these M codes in the operator's manual if needed. Again, keep in mind, APL mode must be activated for the APL to function automatically. Select the part program for the parts you'll be loading, then select the APL program that corresponds to that part program, and then press Insert to activate APL mode, and you're ready to start. As we mentioned earlier, you'll need to create custom templates and grid patterns to match the parts you'll be loading. You can create a template out of sheet aluminum or steel, as we have here using a plasma cutter. If you have access to a laser or water jet table, that would make this even easier. Another simple low-cost way is to make measurements on a thin sheet of plywood or cheap plastic, and then make your cutouts using a jigsaw or router. Pegboard style layouts and similar approaches could also allow for adjustability in the positioning. Whatever method you choose to make your template, here are 3 things to consider when you're developing the grid to locate your parts. First, allow adequate space between rows and columns for gripper clearance. Second, all rows must have equal spacing. And third, all columns must have equal spacing as well, but it can be different than the row spacing. With all that we've covered here, we hope that you'll be up to speed using your APL right away and enjoying the benefits of your newest operator. That's all for now. Thanks for watching.